Hello everyone, it's another beautiful day. Welcome to my online class. Today we'll be looking at 2015 National Mathematics and Science Olympiad, first round. The question says a frustum of a pyramid is 3 centimeters squared at the top and 6 centimeters squared at the bottom, and each centimeter, which is given as the height, and that is unknown. The volume of the frustum is 105 centimeters squared. What is h? That is what is the height of the frustum. For us to be able to solve this question proper, or for us to be able to analyze this question well, how do we do? Let's try and illustrate this on a diagram. Illustrating it on a diagram is going to give us what we have on the screen here. You can see that the shape of what we have at the top here is square, which is 3 by 3. Okay, that's 3 centimeters by 3 centimeters. Okay, and the shape of what we have at the bottom is also squared, which is 6 by 6. All right, and we're looking at the height of the frustum. From the question, volume is given, okay, and the size of the square at the top is given, which is 3 by 3. And the size of the square at the bottom is also given, which is 6 by 6. In solving this, how do we go about this? Let's take a look at this formula. This formula is going to take care of the height given the information, with the given information that we have from the question. Okay, the volume is equal to h over 3 into bracket s1 plus s2 plus square root of s1, s2. We know the volume already from the question, which is 105 centimeters squared, okay? H is unknown, and that's what we're looking for from the diagram here. So what is our S1? What is our S2? So that's the next question. How do we know, or how do we find our S1? How do we find our S2? S1 is talking about the area of the square at the top here, and S2 is talking about the area of the square at the bottom. So in a nutshell, S1, S2, they are both talking about the area of the top and bottom, okay, of the frustum given. That is what we have here. S1, S2 is equal to area of top and bottom of the shape given. Okay, from here, if we take the area of the top here, this is a square, okay? And to get the area of a square, that simply means what? 3 times 3, and that's going to give us 9. And this is what we have here. And going by the shape at the bottom here, which is also a squared, okay, that becomes 6 times 6, and that is 36. So we have our S1, we have our S2. Of course, from the diagram as well, from the question, we have our volume, which is 105 centimeters. So let's try and substitute all that we have into this formula. Substituting all is equal to this. We have our volume to be 105, H is still unknown, over 3, and looking at our S1, S1 is 9, and what is our S2? S2 is what? 36, and that's what we have here. And the square root of the product of S1 and S2, which is 9 times 36, that's what we have here. So let's solve the one in the square root first. 9 times 36, that's going to give us what? 324. Of course, 9 plus 36 as well will give us 45. So we have 105 is equal to h over 3. 9 plus 36, like I've said, is equal to 45. And square root of 9 times 36 will give us square root of 324. If we take the square root of 324, what is that going to give us? And of course, once you get a square root, we can as well cross multiply using this 3 to multiply 105, which is going to be the next thing we're going to do. So we'll be looking at 105 is equal to h over 3 is to bracket 45 plus the square root of 324 is 18. So add this together, then use this 3 to multiply on 5. What do we get? We're going to get 315 is equal to 63h. Divide both sides by the coefficient of h, which is 63. And what will be the value of h? The value of h is going to be equals to 315 divided by 63. And when you divide 315 by 63, what do you get? H is going to be 5 centimeters. So the height of the frustum of pyramid given is 5 centimeters. Thank you.